Okay, so this is a really cool. This is a really cool little way to look at the Sierpinski triangle, and this is using Morphon. I guess I'm just going to call it Morphon. And you'll notice that there's like basically differentiation here, where you get these. So what's going on, right? Well, we've got three different initial transforms in the set, right? That's what forms the Sierpinski triangle in the iterated function system. But what ends up happening is the transforms each have their own deformation, their morph transform set. So, and that morph transform set evolves if I press spacebar. But what essentially that does is it does this search through a 9-dimensional space to find the, I don't know, just to find different shapes and different patterns. And what I've found by observing this system is that it always, when I'm using this fifth mode that I've put in, which uses the iteration coefficient for controlling part of the shape, what ends up happening, also this is also using a spherical transform, so that's why you're getting these more rounded and even better grouped, basically, colors here. Anyway, the point is that each of these points, blue, green, and red, they all have different transforms on them, as you'll notice. Like if you were to look at each of these, sort of the areas around those points as different things. Let me just change up the resolution on this real quick. So if you were to look at the areas around those, this one did sort of like this much more like a wavy, sort of toroidal, veiny pattern, right? And this one did a pattern that's much more like coral, and this one did a pattern that's something like, you know, these like periodic things with like a little bit of a rotation on it, right? Because you can tell from the rotation, because technically this part right here that you see of the green, you can tell that it's so this is part of the green, right? And it's biggest in the green, which means that this feature comes from the green node. And then you can see it repeated here in the other parts of the fractal, obviously, as it goes towards blue. And the coralness feature of the blue part of the blue node comes into green, and you can see like these sort of this part of this feature here where there's like these circles, and I think this is the biggest circle, and then you can see those three circles sort of repeated here and then down on as you get into there. So what's happening is that these three fields are interacting with each other in a way that affect each other in two directions, bidirectionally. And this one, so what ends up happening is like you get this thing here where it's like you get this weird sort of veiny toroidal feature that turns into a coral feature. And you get these spikes on the other end that come from this spike. So it's pretty cool. Anyway, that's one of the features of this. So this is kind of like you're taking the shape, and each of these points it could serve as its own shaped fractal, which would be 100% self-similar. But what's actually ended up happening is that you're mixing the fractals as each of these nodes, so to speak, to create a third fractal that's a combination of all of them. And the coloring is kind of telling you what comes from what, based off of color mixing, so you can sort of see it.